Now in this video I'm going to talk about source code management and start looking into the Atmel Studio and how to get it running. Now source code is managed under the umbrella of a project, and the project can take on any name that you want to give it. Let's say we're going to do something that's a data logger, and it's going to log GPS signals or GPS locations and an accelerometer and perhaps a pressure sensor, a atmospheric pressure sensor and a temperature sensor, stuff like that. And you're going to write software for it to read all that information and display it on a liquid crystal display, an LCD. And so you could call your project data logger. And the minimum source file that you need, or the minimum number of source files that you need for your project, is 1, and it can be given any name as well, or the best way to do it is give it the same name as your project. And now in Arduino they talk about methods, which are chunks of code that just do something and then they finish, and then they go on to doing something else. In C they're called functions, and they're written the same way as the methods in C++, but I'm going to be using C all the time for this video series and not C++. I don't see any particular advantage of using C++ for this size of an embedded controller projects. But so the minimum file you're going to need is 1, and inside that file it has to contain one function, and that function has to be called main. And if you don't include main, you'll get an error when you compile. And the reason for that is main is where all the work is done in the project. Now, those of you that are familiar with Arduino, you never saw the function main. It did exist in Arduino, and because Arduino was just C or C++ that it was using, C++ still has to have a main as well. But the file, or the function main, was buried in some other source file that you never see, that you don't have any knowledge of. If you dig around in the on your computer in the directory where the folder where Arduino is kept, you'll be able to find all these source files, and you'll eventually find one called main. In fact, in main it has two functions inside it, and it's simply one function is called setup and the other function is called loop, which are the two functions that you have to write when you do your Arduino code. I'm not going to do it that way. We're going to do everything in main, and you're going to write your own main. Now, a project like this data logger idea is going to get quite complicated. There's going to be a lot of code. There's going to have to be some way of communicating to the accelerometer and the pressure sensor and the temperature sensor and the display and so forth, and the GPS unit. And each of those has a different kind of a serial interface, and so you'll need to write software to operate the those different types of serial interfaces that are inside the microcontroller, and to get it to communicate with your main routine to get the data out, etc., etc. Now let's look at it a little differently here. Whoops. I'm going to bring up a lot of confusing stuff here. Now, the accelerometer has a lot of these little breakout board sensors that you can get: accelerometers, magnetometers, compasses, gyroscopes, and pressure sensors, and temperature sensors, etc., etc. Most of them will communicate over the I2C communication bus. I think Arduino calls it wire, and Atmel calls it TWI, which stands for two-wire interface. But I2C is the it's a copyrighted name, and so that's probably why they're not using it. But I2C is what everybody talks about. It's just a type of serial communication, and inside the microcontroller, the ATmega 328, there's an I2C peripheral, and it can be used to talk to other devices that are on the I2C bus. Now, the display, for example, might use the SPI bus. It's another form of serial communications. It has a different format than the I2C, and there's a separate peripheral inside that as well, inside the microcontroller as well for that. And the same with the GPS. It'll probably communicate over a UART, a serial, another form of serial port. And again, there's a peripheral inside the microcontroller that's called a UART that will communicate over that particular protocol. And what you're going to have to do is write software for each of those three different types of serial ports. And what you would likely be doing is that on the next project you're probably going to want to use these things again, but you don't want to have to cut and paste the code. So it's often better to put that type of code that just communicates with the I2C into its own file, and I've called it here I2C.c, and the same with SPI and the same with the UART. And that way you've got code in here that you could just concentrate on this code and write routines that test it and fully debug the code in here, and then you're done with it. And then all you have to do is include this file in every other project that needs the I2C. The same with SPI and UART. Now again, these boxes here represent separate files. I wasn't very clear on that. So this is the driver code for the accelerometer, for example. ADXL345 is a very common accelerometer. You can buy breakout boards for them everywhere on the internet. They're dirt cheap. And it uses the I2C interface, or I2C protocol for communicating. And in here you can put routines that read the X, Y, and Z, or Z if you're US, in the US, data for the 3-axis of the accelerometer. You can also write routines in here, functions in here that will allow you to start up and run the accelerometer. When it powers up, it comes up in a sleep mode, and you have to wake it up to get it to work. And so there could be an initialization function in here, as well as the function that gets the accelerometer data. And the same with the liquid crystal here. You could put an initialization routine there that wakes up the liquid crystal display and sets it up the way you want it to work, and then functions in here that write characters to the display, puts them on a certain location on the display, clears the display, all kinds of different things you can do. And again, you would just write the code for this one device in this file here, and do it independently of everything else and get it working, and then you can forget about it. The next time you want to use the accelerometer, the code's already written, you just include it in here, in your main project file here. Now, the way the C compilers work is that you have to compile each of these files one at a time independently. The compiler will look at the file, run through it, and compile it. So everything that the compiler needs to know about this file here has to be either pointed to by something in this file or actually inside this file, and same with all these other files as well. So that's what these .h files are for. And so when you've created this driver for the I2C, you'll create another file called the .h, or the header file, or the I call it the header file, or the .h file, the include file, which tells this and everybody else outside of this module what's going on in here. It's the interface, the public interface. And the same with your project. The project needs to know about this guy, but it doesn't need to know about I2C. So you only need to include the header file for this one, and so the .h file. And so that's how the C compiler does. So inside your file you'll have a directive called #include, followed by the name of the .h file, and possibly the full address of it where it's located on your computer. And then what the compiler does is it simply reads the file in right where it finds that statement, that #include statement, and reads it in and remembers the information in this file, and then continues on compiling the rest of the file until it reaches the end. And so that's pretty much how you manage your source code in a project. And the reason why I suggest that you do these separate little files like this is that once you've got them cleaned up and debugged, you don't have to worry about them again. And you don't have to do any cutting and pasting. And also it keeps this file here where your main work is being done smaller, because you don't have to include all of the code from in here, and all the code in here as well. The compiler will take care of it, and then the IDE, the Atmel Studio, will you have to tell Atmel Studio that you want to include this file and this one and this one and this one, and so it knows to compile these things, these separate files. And I'll show you how to do that when we get into Atmel Studio. But this may sound like a complicated way of doing all your software. You know, you might think, well, it might be a lot easier just to put it all into this one file. But believe me, when you've got 5 different files worth of code in one file, it gets really cumbersome scrolling around back and forth through it trying to find where you are. And so if you put these in separate files, even if you haven't completely debugged them yet, that's an easier way to do it. And sometimes there might be a specific chunk of code for this file here, for this project, that's only unique to this project, but you don't want to clutter up this file. Then you can create another file and include it into here. That's another way of doing it. So hopefully my quick explanation on how to manage your software source code, it was fairly clear. And those of you that are familiar with Arduino, Arduino does exactly this. It's just that what you see is only this part here. In fact, you don't even see main. They've hidden all of this stuff from you so that you don't have to worry about it. All these different driver routines are already made for you, and it just, of course, makes it a lot easier. But you're also reliant on the way that they do it and not the way you want to do it for yourself. And again, I'll reiterate that my series of videos here is not to throw away Arduino, but it's just to help you get a better understanding of how the microcontroller works so that you can write your own stuff like this, and or take somebody else's libraries that may not work properly for you and modify them so that they do work. So anyways, here we are with project management. I won't go too much more in that. I'll probably talk more about it as I go along. Alright, this is what you get when you first start up Atmel Studio, and it looks very complicated. It has a lot of features, many of which you probably won't be using, but I'll go through them. The ones that you'll be more likely to use, I'll go through them all. Now there's these 3 main windows within Atmel Studio, and this one here is the window that you'll be doing all your editing for your code in. Atmel Studio has a built-in browser, an internet browser, so when you click on some of these, it brings up an internet connection and a lot of hints and tips for working with Atmel Studio and Atmel products. Now over here, this window is called the Solution Explorer. They kind of mix up or intermix the word solution with project. And I think what it means is that you can have a number of solutions open in here which are different projects, but I'm not quite clear on what they're doing with this. I only have one project open at a time, so and it seems to work. And down here is a window that shows the output of any errors or messages from your compiler when you compile it, and like this window here or this window here, so it shows you your errors, the warnings, and anything else that comes up. This is useful because it tells you whether you compiled your code properly or not. So to get started, you have to create a project, like I mentioned earlier in this video. So you just go over here to New Project. Now if you want to spend some time playing around with this, you can open up an example project. They've got some that come with Atmel Studio, but I'm not going to talk about those. I'm going to go to a New Project. So we'll click on that, and it gives you a number of different options for starting up a project, including you could create a project from an Arduino sketch. So if you've already got an Arduino sketch going, you could open it up in here. Now I haven't tried that for myself. Like I said, I don't do stuff in Arduino, so I really haven't tried it, and I don't plan on doing that. So we're just going to focus on C++. Now Atmel makes a bunch of different boards that you can buy at a reasonable price. They're not very expensive. They got a lot of features, like this one has a display, and it's to highlight their different products. And so you can open a project that's related to a particular board if you decide to buy one of those boards. but we're not going to do that. So what we're looking for here is this one, GCC C executable project, and it's just either C or C++. And you click on that, and then you have to give it a name. So this will be the project name, and let's say the first project I'm going to do with you guys on the next video, not in this one, I'm going to call it Blink, just like you have in Arduino. And you want to find a location of where to put it, because it will create some directories or some folders for all the code, unless you don't tick this. This is normally ticked. And then it automatically gives the project or the solution the name Blink. So I'm not sure where I want to put this right now. I don't want to put it into Atmel Studio. I think what I'll do is I'll just throw it in the documents for now, and we'll go from there. And then, because I'm not going to use this one, I'm going to probably throw it away or move it somewhere else. So anyways, I'll show you where it shows up in the folder. So you click OK, and it's creating a bunch of stuff. Now you got to pick what's your processor. What microcontroller are you using? It's a big long list. Atmel makes a lot of products. So we're looking down here for the ATmega 328. I don't have any P versions, so I'm just going to click on the 328 non-P version. And it brings up this window here. These are links to web pages, I believe, and these are the different tools that you can use to program your microcontroller and debug it too. Atmel Ice is the one I have. I showed you in the previous video. And does it have, oh yeah, the AVR ISP Mark II is another tool. The AVR Dragon, I didn't talk about that. It's a bare board programmer, and I believe it's a debugger as well. I've used it before. It works fairly well, except it's bare board, and it means it's vulnerable to getting zapped by static electricity, and you might find that you might kill it over time because you touched it and you gave it a static shock. There's other ones here. I think these are all Atmel products, not second-party ones, third-party ones. So anyways, you select your controller, you go OK, and now we're going to create, and it's going to come up with a blank file with your main function in it once it's finished doing all of this. So what it's doing in the background there is it was creating the directories and putting in a bunch of other files that you don't have to worry about, but the Atmel Studio needs that. So here it's created my main.c here, and which is a folder or a file, and then inside the file is my function main, and then you can write your own code in here. Now I didn't talk about that before, but I think you guys figured it out when you're using Arduino, is that the microcontroller wants to continuously run, so it's got to keep doing something. So you generally run it in a forever loop, and that's what the loop function is that you write your Arduino code in. And here in main, you usually use a while 1. So 1 is considered true. So while true, execute the code inside these brackets. So that this is a forever loop, and you get into this loop here, it'll always be running around in this loop executing stuff. And so this is basically all it is for creating your first project file, or first source code file with the function main. Now I can include, or I can write my own functions in here as well. Start with something like this is very typical. Foo is a very typically used word in instructions on how to write software. And we'll make it a void as well. And there, I just created another function that does something different. And if I wanted to use the function here, I can call it. There, that's how you do it. So that's the basics of creating your first source file. I'll show you how to write code in it later. Let's go over to the Solution Explorer here. This is interesting. So down here you see main, it's listed there, and if there's any other files that I've included, source code files I've included in here, they will show up down here. In here is, this will have a little arrow after it if you've got a bunch of include files here. By the way, I forgot to mention this. This is a general purpose include file that you will have to have this statement in all of your source code files. What this does is just gives you a list of all of the registers that are used, that you use to control the I2C peripheral or whatever, and all the names of all the bits in the registers that you have to toggle or do whatever you need to do to get the I2C, for example, interface working. And all of the names of those are already defined for you, and the names follow the data sheet exactly, or very close to that. So when you're reading through the data sheet and you want to do something to a particular register, you just use the register name that's shown in the data sheet, and it's already defined for you in this file. If you include your own include statements here, and then you compile it, they will show up under this, and you'll get all the .h type files. And then in here in this folder shows you all of the files that are created after everything's compiled. And I won't talk about it much right now, but you can see that later. Or let me see, I'll talk about it later when we get more into writing our first project. I'll start off really simple, and then we'll get more and more complicated. Now, previously in this video I talked about creating some other source files, and you have to tell Atmel Studio that you want to compile those files too. So you go to the Solutions Explorer and you right click on the solution title or the project title, and you go down to Add, and it says Add New Item. So if you want to create a new file that you haven't, a new source file that you haven't you don't have already, you can use this one here. Or if you've already created a source file somewhere else and you want to include it in the compiling of this, you click on Existing Item, and it'll open up a browser window like this, and then you go and find it. It'll be something .c, and you click on it here so that it shows up down here. And then if you click Add, what the Atmel Studio will do was take a copy of it from the source directory, which may not be anywhere near your project directory, and you'll take a copy of it and put it into your source directory, your project directory. And you don't want to do that, because then you end up with a whole bunch of different copies. Every project directory will have copies of your I2C.c file or whatever. So you come down to this one, you click on Add as Link, and I haven't included anything, that's why you got the error here. And it'll add it to this list here, and then you can just go to this list and double click on it, and it'll show up in here under another tab. And you can have a whole bunch of tabs across here of all the different source files that you're working on at the same time. Again, this is just a quick overview of how this works. I will go into more detail later on when we start building a project. So once you've got all the files loaded up into the project here, you click, well, these two buttons here are for saving files. So save the file that you're active. This is the file that's active, so this will save the active file, but you might have more than one file here that you've made changes to and you forgot to save. So you can just click this button here, which saves all the files that are up here, and then you can see that asterisk went away here. If you click the compile button, which is this guy here, it will automatically save all files that are open and then start to compile. So when you click on compile, hopefully this will work. You can see a bunch of stuff coming up here. And so build succeeded. And then you can scroll back through this and see the output of the compiler. And then this part here tells you how big is your code and how much program space you've used up and how much RAM you've used up here. And you keep looking through all this. There's a lot of gobbledygook here that's really hard to understand. Once you understand what's going on, you can start looking through this and see why your project didn't compile properly. If there were any errors, they would have shown up here, or any warnings, they would have shown up here. Whenever you get a warning, you should investigate it and figure out why you got that warning. Now, after I've done a compile, I go back to this Solution Explorer window, and now I've seen an arrow here next to dependency. And so these are all the files that the see, they're all .h files that Atmel Studio has loaded up. None of these are you really have to do anything with. You might want to look in them if you're curious, but you don't need to know what's going on in these. Just that the Atmel Studio automatically links them in here. But any .h files that you've created and added up here will show up in here as well. And then if you want to edit that file for some reason, just double click on it and it'll open up in here and you can edit it. And then let's bring this back down. Output files. So these are all the different files that are produced by the compiler. Most of them, well, none of them you really don't have to worry about. I guess the one that is key to you is this one called Blink, and it is the file that gets burned into the microcontroller. And then down here you see this tab shows up as well, libraries. So these are all pre-compiled stuff that's automatically linked in by the compiler and the linker in Atmel Studio here. So again, this is just a quick overview. We'll go into more detail of the stuff later. The next thing to look at is this button over here, this one here with a chip with a lightning bolt through it. This brings up the programming window. And so got the window comes up. I've got a programmer already plugged in it. I'm using the Atmel ICE. If you're using something else, it will probably have a different name come up in here. Since the project already knows what microcontroller I'm using, it comes up in here. And then to get this to work, you have to click on apply. It queries the device, the microcontroller, is it there? And then it sets itself up. Most of this you probably don't have to worry about. When you get this window here, it means it's successfully communicated with the microcontroller and it's ready to go. So you want to go down to memories, and it's already loaded it up. You can see the blink.elf file. So this, like I said, was the file that contains the code that gets burned into your chip. And then you click on this button here and it burns it into your microcontroller. I'm not going to do it right now because I've got another project on the go and I don't want to erase the code. You'll see a progress bar down here that tells you how far into the programming process it is. And sometimes if your code's big, it's going to take a few seconds to program it. And then it'll tell you whether it's successfully programmed it or not. So I'm going to call it here. There's a very quick overview of just getting started with Atmel Studio. I encourage you to fire up Atmel Studio and start looking around. One more thing that before I forget, you notice the different colors here. It's kind of like Arduino, except there's way more colors used here. And each color represents a different part of the code. So this is a function, and it gives, so functions are given this color. If you click on this function, check out this window here. It tells you how it was defined. Main goes the same way. And if I look at this, I don't know, it's not going to show up. When you have labels and other names in here and you click on them, they'll usually show up here and telling you how it was defined. If I defined some variables, declared some variables here, and it was somewhere down in the code I used the variable, and I'm curious to know what kind of variable it was, I can click on it and it'll show up in here. And again, I'll get more into detail on that. Also, when you start typing stuff in here, Atmel Studio knows all of the other stuff that's included in here, and it will bring up a little window that gives you hints on what you're trying to type. And so you can shortcut your typing by just simply typing the first few letters of something, and then if Atmel Studio picks it up, you just either scroll down to that, highlight it, and hit the tab key, and it'll automatically fill in what you're typing. And again, I'll show you that with more stuff going on in here, but for now I'll just mention it. It's really useful. It minimizes the number of mistakes you make in typing. It minimizes the number of typos that you make. It can also be annoying too, because it sometimes brings up the wrong word and you accidentally enter it in, and then you got to find it again and correct it. But most of the time it's really handy. It's called Virtual Assistant, VA Assist X up here. Anyways, I've gone on long enough about this, probably quite a bit to digest, but I would suggest that you open up Atmel Studio and start playing around. On the next video, I'm going to start a real project where we'll actually set up a circuit and do something with it. Probably just a simple blink and LED, just like you do in Arduino just to make sure everything's working. So stay tuned and just practice, play around, clicking on different buttons, see what this thing does. Alright, see you next time.